So last time we looked at particular two-variable equations and their graphs. So here we want to look more at analyzing more general two-variable equations. We want to start off with the concept of x-intercepts. What are x-intercepts? X-intercepts for a two-variable equation or for a graph of a two-variable equation. So x-intercepts is what we're talking about. So this is a point where the graph crosses the x-axis. And what is a y-intercept? We want to talk about those as well. Y-intercepts. Well, you might imagine this is going to be a point where the graph crosses the y-axis. Let's see if we can make sense of this. So here I'm going to do a little example where I draw a graph, and we want to determine the x and y intercepts based on the graph. Determine the x and y intercepts. So let's say my graph, here I have my x-axis here, and here I have my y-axis here. And my graph does something funky, maybe. Let's say it does something like this. I'll call this G for graph. I'm going to put some key positions, some key points. I want to label some of these key places. Let's see. Now let's say here we have -3. Here we have 1, and here we have, let's say that this is 3.5. Over here, let's say we have 3, and this is, let's say, 6. Over here, let's say we have -5, and over here, let's say we have -8. So we want to find the x-intercepts and the y-intercepts. The x-intercepts and the y-intercepts. Let's first write the x-intercepts. I'm going to put those in blue. Now that's basically where you cross the, or not necessarily cross, but where you hit the x-axis. So I use the word cross, but it doesn't have to cross. You can just hit the x-axis. So it intersects with the x-axis, the graph. So right here, at -5, oh, there's one to the left at -8, and there's one here at 3. There's one here at 6. So you're going to have actually 1, 2, 3, 4 x-intercepts. Now you can either write those as ordered pairs. You can write those as what? Come on. -8, 0. -5, 0. 3, 0, or 6, 0. This is one way to write your x-intercepts as ordered pairs. That's traditionally the way it's been done, but more so and more so, a lot of times textbooks are now letting you just write the x-coordinate. So they're also letting you write x equals -8, x equals -5, x equals 3, and x equals 6. So here's another way to do it. You can either write it using the x-coordinate method, which I've circled here, or the ordered pair method, which I put in the box above. Either one is fine. Now, what about y-intercepts? Y-intercepts, let's do those next, and maybe a green color. So that's where you intersect. That's where your graph intersects with the y-axis. Y-intercepts. Intercepts. So let's look on the y-axis, see if our graph hits anywhere on the y-axis. Yeah, it hits here, -3. Here at 1, and here at 3.5. So if you wanted to write this in ordered pair form, it would be what? 0, comma, -3, 0, comma, 1, and 0, comma, 3.5. Those would be our y-intercepts. So this is the ordered pair version of the y-intercepts. Of course, nowadays, a lot of books, like ours, are using just the y-coordinate method. They use y equals -3, y equals 1, and y equals 3.5. This is called the y-coordinate method for writing y-intercepts. So, it's pretty easy to pick out x-intercepts and y-intercepts when you just have a picture, when you have a nice picture of a graph. But let's say you don't have a nice picture of a graph. And let's say you just have the equation of the graph. You just have the two-variable equation. We want to figure out a method for determining x-intercepts and y-intercepts when you just have the equation without any picture. So first of all, you want to notice, okay, what about x-intercepts? What about x-intercepts? Notice with x-intercepts that the y value is always going to be 0. Right? The y value is always 0 with an x-intercept situation. So I'm going to write down here to find x-intercepts with an equation. This is what you want to do. So remember, when we had x-intercepts, our y value was 0. So you set y equal to 0 and solve for x. Okay, what about finding y-intercepts? How do you find y-intercepts when you have just an equation without a picture? With an equation. So if you pay careful attention for the y-intercepts, look at the y-intercepts. The y-intercepts. What do you notice about the y-intercepts? The x value was what? Always 0, right? The x value is always 0 when you have a y-intercept. So that's when you're on the y-axis, your x value is always 0. So to find y-intercepts with an equation, you're going to set your x-coordinate equal to 0, and then you can solve for y. Solve for y. So that's going to be our strategy for finding x-intercepts and for finding y-intercepts. Let's do a few examples maybe of that. I'm going to say exercises. Exercises. Find the x-intercepts and y-intercepts of the graph of the equation. Okay, here's our number 1. First of all, we have the two-variable equation x squared minus y cubed equals 64. So this is a two-variable equation. We want to find first x-intercepts. So I'm going to write x-intercepts. So for that one, you have to remember to set y equal to 0. and solve for x. So we're going to have what? X squared minus 0 cubed. No, wrong color. Equals 64. So basically what we've done there, we've set y equal to 0. We plugged in 0 for y. Now when we do that, we're just going to get what? X squared, right? 0 cubed doesn't contribute. It's a non-contributing member, so you just don't pay attention to it. So you have x squared equals 64. And notice that this is a power equation, right? A power equation, right? It's an even power. So how do you solve a power equation? Good question. Well, you write down your variable equals, and you have to remember when you have an even power, you're going to do plus, minus, and you're going to do the square root. Since you had a square, it's going to be plus minus square root of 64. Come on, 64. Ooh, I dropped the 64, right? There we go. So x equals plus minus the square root of 64. That's going to be plus minus 8. So that means there are two y-intercepts, positive 8 and negative 8. Positive 8 and negative 8 are the two y-intercepts. Okay, secondarily, we want to find the y-intercepts. So remember how we said we're going to find the y-intercepts? We're going to set the x equal to 0 and solve for y. So x is going to get set equal to 0 in the two-variable equation, and we're going to solve for y. So here it goes. It looks like I'm going to have blank squared minus y cubed equals 64. So here in place of the x, I'm going to put a 0. So I'm not going to put an x, I'm going to put a 0 in place of the x. So now 0 squared is going to be 0, so that's not going to contribute. So we have 0 squared doesn't contribute. We have minus y cubed remaining equals 64. Now, I want to get y cubed by itself, so I'm going to divide both sides by a negative 1. And when I divide both sides by negative 1, I'm going to get a positive y cubed on the left. And on the right, I'm going to get a negative 64. And then we have an odd power equation. So to solve that, we're just going to drop the cube, and you're going to do the cube root of negative 64. Notice we don't put a plus minus, right? There's no plus minus in front of the cube root, and that's because we have an odd power, right? Anytime you have an odd power here, you're just going to have just the cube root. You don't do plus minus. Plus minus is just when you have an even power. So we have y equals cube root of negative 64 is negative 4. So there you have it. You have two x-intercepts and one y-intercept.